Good morning. Next we will see the derivation of power density from Poynting's theorem. Now we have the solution of wave equation as Ez of t is equal to E naught e raised to minus alpha z cos omega t minus beta z ax. We already derived it earlier. This shows you that this Z shows you that the electromagnetic wave is along the Z direction, and this Ax shows you that the electric field is along X axis. Similarly, the magnetic field H Z comma t is equal to E naught by eta into e raised to minus alpha z cos of omega t minus beta z minus an angle theta n of ay. This theta n represents the angle of magnetic field with respect to your electric field. Okay. So into ay. So this ay represents that magnetic field is along which direction? Y axis. And here you know this E naught by eta gives you H naught, because we already know E by H is equal to eta, which is your intrinsic impedance. So from that I can write H naught is equal to E naught by n. So that is what is written here. Ideally it is H of Z comma t is equal to H naught into e raised to minus alpha z into cos omega t minus beta z minus theta n into ay. Then that H naught is replaced by E by eta. Okay. And this theta n is the angle of magnetic field with respect to your electric field. That's all. Now we have the Poynting vector P is equal to E cross H. So what I am going to do is I am going to take the cross product of 11 and 12. So I will get like this: E naught square by eta into this 2e term will give you e raised to minus 2 alpha z and 2 cos term, cos of omega t minus beta z into cos of omega t minus beta z minus theta n into az. Okay. Why az is here? The theory is, if E is along the x-axis and H is along the y-axis, then the Poynting vector P will be along the z-axis. That means Poynting vector will always be along the direction of your electromagnetic wave. Point to be noted, the Poynting vector P will always be in the direction of your electromagnetic wave. So that is why here it is AZ. Now we know 2 cos A cos B is equal to what? Cos A plus B plus cos A minus B. So we are making use of this identity to solve this particular term. So finally I will get E naught square by 2 eta into e raised to minus 2 alpha z the whole into cos 2 omega t minus 2 beta z minus theta n plus cos theta n into az. Now next I am going to take the time average Poynting vector, otherwise known as power density or energy density. For that what I am going to do is I am going to integrate this term over one time period. This term over one time period. So I can write P average of Z is equal to 1 by t, where t is one time period. Integral 0 to t P Z of t dt. And the next step, what I am going to do is I am going to substitute for P Z of t, which is this one. Okay. So I can write that is equal to 1 by t. That is equal to 1 by t integral 0 to t E naught square 2 eta e raised to minus 2 alpha z cos 2 omega t minus 2 beta z minus theta n plus cos theta n into dt. Now next what you have to keep in mind is the second point. When cos omega cos n omega t and sin n omega t is integrated over a time period t, it becomes 0. All these points you have studied in your mathematics paper. That is, when cos n omega t and sin n omega t is integrated over a time period t, the integral becomes 0. Okay, that means this term, when you integrate this term cos 2 omega t over the integral 0 to t, this term will become equal to 0. So then the second term is cos theta. So cos theta, you know, it will be a constant value. Cos 90 is a constant value, cos 360, cos 180, all those are constant values. So making use of all these points, I am finally writing the above expression as P average of Z is equal to 1 by T, then E naught square and eta are constant, so I am taking that term outside. E naught square by 2 eta, then this e raised to minus 2 alpha Z is also a constant, that is also taken out. Then cos theta n is also constant, that is taken out. Finally I will get integral 0 to t dt. Okay, so what is integral 0 to t dt? That is capital T. So finally this capital T and this capital T get cancelled, and I can write P average of Z is equal to E naught square 2 eta e raised to minus 2 alpha Z cos theta n, which gives you the average power density. Hope the derivation is clear. And the total time average power crossing a given surface S is given by taking the integral of surface integral of P average of Z. That is, if you are asked to calculate the total power crossing a given surface, what you have to do is, first you have to find out P average of Z, then integrate over the closed surface. That is written here, P average is equal to integral S P average of Z ds. Okay. Next we will see complex Poynting vector. Complex Poynting vector. Now we will start with P is equal to E cross H. Now what we are going to do is, we are going to apply time varying condition to the above equation, and we need only the real part of the time varying condition. So I am going to write P is equal to real part of E into a time variable is added, e raised to j omega t into Re into a real part of H into e raised to j omega t. So here e raised to j omega t is a time varying factor, and Re represents a real part. Okay, so we can represent E and H in the phasor form or otherwise polar form as E is equal to E naught into e raised to j theta. Similarly, H is equal to H naught into e raised to j phi. This is a polar representation or otherwise a phasor representation of E and H. E is equal to E naught e raised to j theta, and H is equal to H naught e raised to j phi. Now what I am going to do is, this polar representation of E and H is substituted in equation 1. Okay, so that I can write as real part of, instead of E I will write E naught j raised to e raised to j theta, then this e raised to j omega t into real part of, instead of H I will substitute H naught into e raised to j phi, then into e raised to j omega t. Okay, then I am combining, that is real part of E naught into e raised to j of theta plus omega t into real part of H naught into e raised to j of phi plus omega t. Simply I am combining. Now this E naught is a constant, I am taking it out. So I can write E naught into real part of e raised to j theta plus omega t. And you all know that the real part of e raised to j of theta plus omega t is cos theta plus omega t. This is based on this identity, that is, we know e raised to Ix is equal to cos x plus I sin x. We already studied in our mathematics paper. So if we want to take the real part of e raised to ix, then it will be cos x. So making use of this identity, I am rewriting this equation, this one, as E naught is a constant. So E naught into cos of, here this x, here it is theta plus omega t. So I can write out as E naught into cos theta plus omega t into, coming to second term, h naught is a constant, is taken out, h naught into real part of e raised to j phi plus omega t can be written as cos of phi plus omega t. This is written based on this particular identity. So that is, finally I can write E naught cross h naught into cos of theta plus omega t into cos of phi plus omega t. Then we know 2 cos A cos B is equal to cos A plus B plus cos A minus B. Making use of that equation, P is equal to E naught into h naught by 2 into cos of theta plus phi plus 2 omega t plus cos theta minus phi. We are simplifying this one using this equation using this identity. Okay. So we will get this one. Next, what I am going to do is I am going to integrate this one over one time period. So P average is equal to 1 by t integral 0 to t p dt. So as I said earlier, this term will be equal to 0, because if you integrate sin n omega t or cos n omega t over one time period, it will be equal to 0, and this term cos of theta minus phi will be a constant. Then obviously E naught and h naught also constant. So I can take E naught, h naught and cos theta minus phi outside the integral, and finally I can write it as E naught h naught by 2 into cos theta minus phi into this 1 by t integral dt. Okay, 0 to t dt. So you can write it as, when you integrate this term, you will get t, then this t and t get cancelled. Finally we will get E naught into E naught cross h naught by 2 into cos of theta minus phi. Then in the next step, what I am going to do is I am going to write it as real part of half E naught cross h naught into e raised to j theta minus phi. This is same as this. Okay, because here you can see real part of half into E naught cross h naught into e raised to j theta minus phi. If you are removing this real term, RE term, how can you write? You can write it as what? Half into E naught cross h naught into cos theta minus phi. Right. So this term, this equation and this equation, both are the same, represented using two different forms. That's all. So we have real part of half into E naught cross h naught into e raised to j theta minus phi. Then what I am doing is I am slightly opening the bracket of this e raised to term. So I can write real part of half E naught into e raised to j theta into h naught into e raised to minus j phi. I am just opening the bracket of e raised to j theta minus phi, so that I will get e raised to j theta and e raised to minus j phi. Then that e raised to j theta is written with E naught and e raised to minus j phi is written with h naught. So that I can write it as real part of half into E naught e raised to j theta into h naught e raised to minus j phi, which is written as real part of half into E naught e raised to j theta. Here it is what it is written as E. So I have taken it as E. Similarly, what is h naught into e raised to minus j phi? It is h complement, because here we have taken h as h naught into e raised to j phi, but here in this derivation we got it as minus j phi. That's why we have written as h complement or h star. So finally I can write P